The final reaction in this chapter really goes through a completely different, unique mechanism, and that's the hydroboration-oxidation. This is a second way to hydrate an alkene, but we're going to see that it does not follow Markovnikov's rule, so we're going to call this an anti-Markovnikov addition. Recall that when you hydrate under acidic conditions, you get the Markovnikov product where the hydroxyl group ends up on the more substituted side of the alkene. And if you can't remember exactly why that is, remember it protonates on the less substituted side, so the carbocation's on the more substituted side, and that's where the water is going to come in and attack. We're going to see that if you use hydroboration-oxidation, that you get the hydroxyl group on the less substituted side of the alkene. So once again, this is an alkene to alcohol transformation. And the mechanism looks something like this. The pi electrons of the alkene will reach out and grab a hold of the Lewis acidic boron. The boron is actually going to lose a hydride that's going to form a new bond to the carbon here. The boron will go to the less substituted side because of sterics, and the hydride is going to go to the more substituted side, so you're left with BH2 over here. And we're not going to look at the stepwise mechanism of the second part, the oxidation step, but what happens is wherever the boron is, you're going to get a hydroxyl group that substitutes for that. So since it's on the less substituted side of the alkene, that's where your hydroxyl group is going to go. Notice that the hydrogen and the boron that are being added across the double bond in the first step add to the same side, the same face of the pi bond, and so this is called a syn addition. So if you want to look at it from a perspective drawing, kind of more a three-dimensional perspective, the hydrogen and the BH2 are always going to be directly across from one another during the addition, but notice on this side where the boron's adding, the less substituted side, there's actually a chiral center, and so there's two possible orientations that could develop. And after the final oxidation step, notice that you end up with a set of enantiomeric alcohols.